Okay, so in the middle of page 13, again, we were talking about this region here. So what happens is when this is revolved all the way around, you get this shape here. And what we have is this circle that is formed by the top, f of x, all the way to the axis of revolution, which is here. Okay, and I'm going to call this capital R. Okay, so it goes from the top, meaning this top, f of x, all the way down to the bottom, which is this axis of revolution, which for us is going to be the x-axis. And then what you have is this being equal to r, because it's f of x minus 0, technically. And then we have this small region right here, from g of x, which is the bottom, so it's this part, okay, minus 0, which we'll call small r. So what we have is this little teeny circle here, and then this big circle here. Okay, so if we cut that out and we bring it up right here, what you have is this big piece, we'll call this one right here, big R. Okay, so this one was the pink, which is over here. Then you have this small radius, which was g of x minus 0, which was right there, and I labeled it green, so we'll say little r. So what we're looking for is the region of this big circle, which would have been one solid, minus this little circle. So then it's going to be this, which is what we're looking for, which is what creates this washer right here. Okay, so if you think about finding the area, let's say the area of the larger circle, it would be pi times this big R squared, that's the radius, and the area of the smaller circle, which would be pi times little r squared, which is this one. And if I take this one minus this one, it's going to give us the area. So if I say the area is equal to the big circle minus the little circle, we can actually factor out the pi. So the area is going to be equal to pi times big R squared minus little r squared. And remember, this was f of x, and this was g of x. So now if we take a look up here at the top, we have our area formula, which is right here. And it's pi times the quantity of f of x squared minus g of x squared, which is what we have here. It's the exact same thing. So now, if you're looking for the volume is actually going to be the integral of that. So in this case, the volume is equal to the integral, and I would actually rewrite it like this. This is equal to pi times the integral from a to b of f of x squared, which we called our r, capital R, minus g of x, which is our little r squared, dx. And again, what you need to consider is that this is going to be the top, and this is actually the bottom function, because this is perpendicular, your cross-section is perpendicular to the x-axis. So with respect to x is always top minus bottom, from left to right. Okay? All right, so let's take a look at an application of that.